Hello friends. So today we will learn how to write a program to find sum of geometric series using formula. If you see the playlist, we had created one video where I told you how you can find sum of any geometric series. So this video is about how to find it using the formula by directly applying the formula and reducing the time complexity. So what is a geometric series? Basically, the ratio is same in geometric series. If you see 110, if you multiply it by 2, it will be 220. 220, if you multiply it by 2, it will be 440. 440, if you multiply it by 2, it will be 880. And 880, if you multiply it by 2, it will be 1760. So it is the multiple is 2. The multiple is constant, or you can say that the ratio is constant. If you divide the 220 by 110, it will be 2. If you divide 440 by 220, it will be 2. So that is constant here. So this is our formula. If the ratio, that is 2, if it is less than 1, if the ratio value is less than 1, then the sum formula is A into 1 minus R raised to power n divided by 1 minus R, where R is the common ratio, that is 2, and A is the first term, which is 110, and n is the number of terms, which is 5. And in case if R is greater than 1, so if we see in our case, R is greater than 1, 2 is greater than 1. So our sum formula is A, R raised to power n minus 1 divided by R minus 1. So so the input from the user here will be, we need the value A, we need R, and we need n, number of terms. And then after taking the input, we will put a condition. If my R is less than 1, then I will use this formula. My sum will be this. Initially, I will put my sum as 0. Okay. Okay. So this is my input. Initially, my sum is 0 and my input is this. And if my R is less than 1, then my sum value will be sum plus this. Okay. And else, if my R is not less than 1, if it is greater than 1, then my sum value will be, it will be A R raised to power n minus 1 divided by R minus 1. And then at the end, once I calculated the sum value, I will simply print the sum value. So let's dry run it once. So it is nothing. Suppose if my A value given by the user is 110 and R value given by the user is 2 and the number of terms given by the user is 5. So initially my sum is equal to 0. I will put it in the formula. My formula will be this. A is 110. So my R is greater than 1. So it will go into the else part. Okay. So R raised to power n. So 2 raised to power 5 minus 1 divided by R minus 1. Minus 1 divided by R is 2 minus 1, which is 1 only actually. Okay. So if you solve this, so use your calculator and solve this. So if you see 2 raised to power 5 is 32, 32 minus 1 is 31, this denominator is 1, and 31 into 110 will be 3410. Okay, so this will be our sum value. Let's go to our Eclipse and write this program. So let me create a new class. So let me give the name of the class as geometric series using formula. And I will take public static void main so that it is auto-populated. The main advantage of using the formula is you have solved your problem in order of one complexity. There is no loop, nothing. It is just simple putting the values in the formula and finding the answer. So it is quicker. Okay. So let me create a class scanner so that I can take the inputs. I will import my scanner class. So let me ask the user to enter the value of n, and let me take three variables, int n, a, and r, and initialize my sum. I will take double because there is denominator, so there could be chances of some value being in points, in decimal. Okay. So I will, so in the n value, in the n variable, I will store my n value. That will be integer. Number of terms will be integer only. And then in the first term, I will get my first term from the user, and I will store that in a variable. And our first term will also be an integer. Now I will get the value of the common ratio. And that I will store in R variable. That will also be an integer. And let me write and enter number of terms here for clarity. So I got all my inputs. Now I will apply the formula. If my R is greater than 1, okay, so my sum will be sum plus. So what is the formula? A R raised to power n minus 1 divided by R minus 1. So A into, I will use math.pow function, and R raised to power n minus 1. Okay, minus 1. Okay, A is getting multiplied with this math.pow. I can remove these brackets. Okay, so A into, let me put this also in bracket. A into math.pow R raised to power n minus 1 minus 1. Now, divide this by, it is R raised to power R minus 1. Just saying some bracket mistake. This is, okay, this is not required. Now it's correct. And this is when my R is greater than 1. If my R is less than 1, then my sum will be A into, now it is 1 minus. Okay. A into 1 minus mat dot power r raised to power n minus 1 divided by 1 minus r. And then outside, I will print the value of my sum. Let's save the program and let's run it now. So number of terms I will enter as 5. First term, you see my first term was 110 and my common ratio was 2. So I got my answer 1650. That was the, oh, that is not the expected answer. I think our A should be multiplied after calculating the numerator divided by denominator. A should be multiplied at end. Let's try that. I will just remove these brackets. Okay. And I will put bracket on the division part. Let's see if it works. There must be some issue with the brackets only. That's why the answer is not correct. Let's save it and let's run it. Enter number of terms 5. Enter first term 110 and enter common ratio 2. 1650. Again, it's not correct. I'm sorry for the confusion. I just realized that I applied the wrong formula. If you see, it is a r raised to power n minus 1 divided by r minus 1. So a r raised to power n minus 1 divided by r minus 1. Similarly, it is 1 minus r raised to power n divided by 1 minus r. A into 1 raised to power r, not n minus 1. I don't know why I took n minus 1. And then 1 minus r. So it is r raised to power n, not r raised to power n minus 1. R raised to power n and then minus 1. Let me save it and let me run it. So number of terms are 5. First term is 110 and common ratio is 2. So now we got the correct answer 3410. So take care of the formula. So to solve it using formula, you must remember the formula correctly. A into 1 minus r raised to power n divided by 1 minus r and the reverse. And also you can put one more edge case here. So when our r is equal to 1, so suppose when my r is 1, okay. So if I apply it in the this formula, so it will okay, let's stop applying it in the formula. If my r is 1, so how will my series be? Let's consider 2. Okay. 2 into 1 is 2. 2 into 1 is 2. 2 into 1 is 2. It will be same. Okay. If I consider any other number, 110. So 110 into 1 is 110 into 1 is 110 and so on till your n number of terms. So if I want to calculate its sum, it will be number of number of terms into 2. So suppose there are 5. So 2 plus 2 plus 2 plus 2 plus 2. It is same as 5 into 2 and the sum will be 10. Right? So let's cover this edge case also here. If r is greater than 1, then this is our formula. Let's move the else part back. Else, if r is equal to 1, then our sum will be, actually you can also remove sum equal to 0 if you want. You can just simply put it in the sum. Oops. Or you can keep it. It's your choice. You can directly give the value of sum or you can keep it. So sum equal to sum plus, and that will be number of terms into, you can say, your first term, right? And then r, else part, else your r is less than 1, and then you will follow this formula. So let's run it. If my number of terms are 5, my first term is 2, and my r is 1, then I will get the value as 10.0. So I hope you understood this program, and you can see that it is showing a warning SC is never closed. So you can close your SC at end to remove this warning. Inside your main. You can see now the warning is removed. So this is how you write a program to find the sum of geometric series using formula. The time complexity is order of 1, so it is quicker. Hence, if you remember the formula, you can use this method. Otherwise, if you don't remember the formula, you can watch my previous video on how to calculate the sum of geometric series. If you like this video, then please make sure to subscribe to my channel. Thanks for watching.